Okay, I think we're live now. Just give me a second. Okay. Can everybody see the discussion slides? All right, so today we're just gonna do some probability and counting problems. Let's jump into the first one. So, oh wait, I have to use the tool. Okay, so it asks, what is the probability of getting more heads than tails on 4 tosses of a fair coin? So what are the possible ways, what are the possible ways to have more heads than tails of 4 tosses? So for each coin, we can have either head or tail, 2 choices, and we have total 4 tosses. What are ways to make more heads than tails?
So
3 heads or 4 heads.
Oh,
Sorry, is it 3 heads or
3
4?
heads or 4 heads, yeah.
Yeah. So we can have 3 heads or 4 heads. And these are the 2 cases. And we know that so we want to find out the probability of getting more heads than tails. So we can just directly use the definition of the probability, which is PE, where E is your event that we have more heads than tails. And the probability of PE is equal to the number of the outcomes over that more heads than tails happen over the number of sample size, which is NS. So let's first find out what is the sample space. So what are the outcomes if you just have 4 tosses of a fair coin?
would it be 2 to the 4th?
Yep. It would be 2 to the 4th because you have 2 choices for each toes and you have total 4 tosses. And that would be 2 to the 4th. And that's 16. And this is your sample space. And what about the number of events that more heads than tails on 4 tosses? Which I have 2 cases where you can have 3 heads or you can have 4 heads. And you want to plus these 2 cases together.
So I think there's 4 ways to get 3 heads and then 1 way to get 4 heads. So it would be, oh wait, sorry. Yeah, 4 and then 1. So it'd be 5 ways in total.
Okay. So yes, that's actually correct. So if you, let's just say you have 4 spots for the 4 tosses any one of 3 heads, just basically mean just choose any 3 spots that can place the head, or it should be the same as C. 4-1 should be, or equals to C 4-3. And this one is like choosing one of the spots that's tail, or choosing 3 of the spots that are heads. And this is where the 4 comes from. And one head's just going to be C4, choose 4, because once we have 4 spots and you want all of them to be heads, and there should be only one outcome. And then you have a probability of over 16. And this would be your final answer. All right, any question on this one? Okay. Let's move on to the next one to find the expected number of games. So if the Bisons have a 3/5 probability of winning any given game against the Mustangs, what will be the average length of a best of 5 series between these 2 teams? So it's the number of games played until one team has, there's a typo. Should be 3 games. And okay, so right here is asking about the average length, which it's the same as counting the expected number of the length. So let's just first think about like what are the possible lengths of a best of 5 series.
Three, 4, and 5.
We can have, so let's first let X be the number of games, which is the length. So we can have an X can choose from the set of 3, 4, and 5, which are the possible lengths. And let's first think about when X is equal to 3. What is the probability of that the best of 5 series and end up with only 3 games? Or like the length will be only 3.
Well, there's 2 situations. You have one where the Bisons win and one where the Mustangs win. And you just do like the binomial distribution. So like 2 choose 2 times 5/3 to the 3 times 2/5 to the 0, plus like the Mustangs, kind of the same thing for the Mustangs.
Do you want to say that again? Like 2 choose 2?
2 choose 2 times 3/5 cubed times 2/5 to the 0.
Okay, that's when like a basis win.
Right. And then we would add, for the Mustangs win, we would do 2 choose 2 3/5 to the 0 times 2/5 cubed. And then we do pretty much the same thing for 4 and 5.
Yeah, exactly. So we wanna make sure that in this case, which is basis win in the best of 5 series, and there should be like if basis win the BBB, in this case, which is Mustangs win the 3, which would be MM. And this will give you that 3/5 cubed plus 2/5 cubed.
There is a question in the chat about why isn't it combination 3 choose 3?
The combination right here, this one,
I believe so, yes.
because we only have 2 teams, and the 2 choose 2 here basically just means that, well, I guess I think he is right. It should be 3 choose 3.
Well,
think
in
it-
order to win, you have to win the last game. So you only
Yeah.
have to choose the first 2.
Best of 5.
Oh yeah, I see. So it has to be for basin to be the last, and then you have 2 spots here, and where you can and also like basin wins the 1-3, the links would be 3. So it would be also 2 choose 2. Okay, yeah, I see. All right, and that's when the length is 3, and the next one will be when the length is 4. That you should have 4 spots here for this time, and then we want to make sure the last spot is occupied. To make sure either basin wins or either Mustang wins. So in this case, you will have what's gonna be the combination here?
Three choose 2.
Yep, 3 choose 2, because you have 3 spots, and you want to make sure have 2 occupied, and which gives that still 3/5 cubed. And you also don't forget we also have the Mustangs that win this time, which is 2/5 to the 1. And it should be similar for Mustang wins. 3 choose 2. And this time it should be 2 to the 2/5 cubed and times 3/5. And then, so the last one would be we're gonna find the probability that the length is 5, in which we should have 5 spots here. And we want to make sure that we won the last game. So we can have either this, that's just one option, So right now, this time we will have 4 choose 2 and still 3/5 cubed and 2/5 squared plus 4 choose 2 and 3/5 cubed and 2/5 squared and 2/5 cubed. Okay, so now you have the probability of each of them. So we have the probability when the length is 3, and we have the probability when the length is 4, and when the length is 5. And then we wanted to find out the average length. So it's this. So we're gonna use the expectation to find the average length, which it should be use 3, which is the length times the probability of when x is equal to 3 plus 4 times the probability when the length is 4, and plus 5 times the probability when the length is 5. So this is like a weighted average. That basically means that the length is 3 here, and this is like the probability of like how much it would contribute to the to the final average. And this is like the length of 4, and this is the possibility of getting a length of 4. And this is the length 5 times the probability of getting a length of 5. And this will give you the average of the length. And this comes to some number like 4.0656. Any question, or does this make sense at all?
There's a question, how did you get that number?
Oh, I just skipped the step like compute this 3. So if we go back here, when the probability that the length to 3, this one should be some number like 175 over 625, and this is equal to when the probability of length is 4 is, let's see, 234 over 625. I basically just compute each of this and substitute that in, where you have 3 times this and plus 4 times the probability of that.
There's a pretty good explanation of this on like page 473 about in the textbook.
Yep, you can also read that. And this should give you this number. Okay. So I just assume there's no other questions. We can just move on to the next one. All right, so this one asks, what is the probability that when a pair of 6-sided regular dice are rolled, either at least one die shows a 5 or the dice sum to 8? So one of them either one die shows a 5 or the dice sum to 8. What is the general like rule or probability when you have something when it's asking like either or? Let's see like name the event of at least one die shows a 5 is E1. Or one die shows a 5 is E1 and the dice sum to 8 is E2.
You just add E1 and E2 together, right?
Yeah, so you have the probability of E1 or E2. If you just do the probability of E1 plus the probability of E2, what's the problem of here?
They would be disjoint if that were the case.
Yes, but it's certainly not in this problem. So you have to minus the overlap. Because if you do E1 and plus E2, you will have a double counted, where the case that they happen at the same time. Okay, so why don't we just write out like the what are the, let's first find out the probability of E1 first. Where E1 is that at least one die shows a 5. So we have this. And in this case, what's going to be our sample space? If a pair of 6-sided regular dice are rolled.
36.
And how did you get that?
6 times 6.
Yep. And that's your sample space. And what are the what are the outcomes that at least one die shows a 5?
Well, there would be 10 with at least one, but since we're minusing that later, wouldn't it be 11? Since we're minusing the part that's union or intersecting.
Yep. So that equals to 11. So that basically counts like that basically equals to if only one of die shows a 5 and the other one doesn't, or both of them shows a 5. So if only one dice is a 5 and the other one isn't, there should be 10 ways. And if both of them shows a 5, then that's 1 ways. Okay. And this should give you the probability of the event E1 happen, which is 11 over 36. Then let's find out E2. And it should be the same for the sample space in E2 because we're still gonna roll a pair of 6-sided die. So that's 36. And what about our event E2 happens, where the dice sum to 8? We can actually write this out. Like, what are the combinations here?
2, 6, 3, 5, 4, 4, and 5, 3, and 6, 2.
Mm-hmm. And you can switch the position of this 2. So that's will give you totally about that will give you totally 5 outcomes that the dice sum to 8. So your PE2 is 5 over 36. And you wanted to subtract the overlap, which both of the events happen at the same time. That at least one die shows a 5 and the die sum to 8. Another way, you can just look at this 5 outcomes, like which satisfy that at least one die shows a 5. And then count a number. That would be the, I'm just gonna write here. So still use this formula. See if I can. Okay. So you will have your sample space, and the sample space should be the same as 36. So what are the outcomes that they happen at the same time?
2,
And what are they?
5, 3, and 3, 5.
Yep, and it would just be this 2. So, and the probability for the E1 or E2 will just be, let's see, will he 3611 plus 5 over 36 and minus 2 over 36. And this should give us 16, that's 14 over 36. And that's divided by 2, it's 18. Okay. Any question on this one? Okay. All right, so let's move on to another expected amount. So we need to find the expected value. So we have a player pays $10 for the privilege to play a casino game. The player tosses a die 3 times with the following payoff. So $10 for the first die that shows a 6, and an additional $15 for the second die that shows a 6, and an additional $20 for the third die to show a 6. And part A asks, what is the expected amount of money that the player will win playing the game one time? So we have $10 for the first die that shows a 6. So the player is going to win $10. If you have 1 6 among the three times, and you will get and additional 15 for the second die, which basically means that you will win a 25, and that's 10 plus 15 for you have 2 6 in your 3 times. So let's write this out. So $10 for player to win that if the player only have 1/6 in 3 times. So it's 1/6. And the player will win $10 and plus an additional $15. And that's give you a total $25. For a second die, that shows the 6. And that basically means 2 6. And additional $20 for the third die to show 6. Oops, I can't spell. Okay. So let's just first find out the probability that the player only have 1/6 in 3 times. So the probability of 1/6, or another way saying that the probability of win $10. How do you compute this? So we have the player gonna toss the die 3 times. So basically means we have three spots to place 1/6.
Well, there's 3 6s, and there's 6 times 6 times 6 option sample space, right?
Mm-hmm. The sample space is 6 cubed. And do you want to say that again, like for the event?
Well, there are 3 possible 6s that you could get out of all 3 dice.
What do you mean, like 3 possible?
Well, there's a 6 on each dice.
Uh-huh.
So there's 3 options that could be a 6. That could be a success.
Okay, so that basically means 3 choose 1.
Yeah.
And we have, so we have the one that 1/6. And the other, and we want to make sure that the other 2 tosses does not appear as 6. And that's 5 options times 5. In other words, you can write this like 1 times 5 times 5 over 6 to the cube and times 3. The 3 basically means where you can put the 6. So like you can put the 6 here, or you can put the 6 in the second spot, or in the third spot. That will give you 3 options to put the 6. Okay. And for and this one will give us see. That's 75 over 6 cubed. And the second one is, what are the probability of getting 2 6? Which means that win $25 in this case. So you have 3 spots and you want to make sure you have 2 6.
Five over 6 cubed times 3 choose 2.
Mm-hmm. So the 5 is the one that left. You can choose from the other 5 numbers. And you have the sample space 6 cubed. And the 3 choose 2 is where the 6 you can place. And the probability of getting a 3 6, which means I win a $45. This case should be straightforward because we wanna all 3 spots to be occupied by 6. And still have the sample space of 6 cubed. And that should give you only 1 possible outcomes. Okay, and now you have found the possibilities in each case that a player wins $10 or $25 or $45. And then you just want to calculate the expectation or the expected amount of money. That's just X here. And how do you compute this?
Ten times the probability of 1 6, and then 25 times the probability of 2 6s, and the same for 3.
Mm-hmm. Yep, exactly. So I'm just gonna substitute this the numbers here, which represent the probability of getting 1 6, and 25 times the probability of getting 2 6, and 45 times the probability of getting 3 6. And this would give you about $5.42. So this number is the average amount of money a player can win in one game. And the player has to pay $10 to play the game.
I think you might have gotten the money wrong because I think it's 15 and then 20, not 25 and then 45.
It's an additional $20, not 15.
Yeah, so right here it says $10 for only getting 1 6 and an additional $15.
Okay, I see.
6, yeah. So you have to add the $10 as well. And an additional $20 for the third die. So that would be 10 plus 15 plus 20. Okay, and the part B asks, how much can the casino expect to make if $10,000 of this game, if 10,000 of this game are played each day? So we're gonna play this game 10,000 times, and how much will the casino expect to win, to get from this 10,000 times?
Well, if you're expected to win 542, then the casino's expected to win 468. Then you times that by 10,000.
And that number comes from 10 minus 5.46 or 442, and you have total of 10,000 games. So this is the amount that a player pay to the casino. And this is the amount that casino gives to the player. For each game. And you're gonna time that with 10,000 games. And this is equal to 45,800 for the casino to make one day. And that's a lot. Okay, so any questions about this one? All right. Next one is we want to choose in a committee. So suppose we have a 3-person committee is formed for a club by drawing names out of a hat. And if the club had 30 juniors and 20 seniors, what is the expected number of seniors on the committee? It's another question asking about the expected number. And it asks about the expected number of seniors. And we want to form like a 3-person committee. So let's write out the expected count as, so what are the possible numbers of seniors in the committee?
0, 1, 2, or 3.
0, 1, 2, or 3. But 0 doesn't gonna count in the expected value, because if you do, when x, just let x represent the number of seniors on the committee. And if we write this out, and this one just gonna equals to 0. All right, so, and we end up only compute the probability of, like, when there's only 1 senior on the committee and 2 seniors on the committee, or 3 seniors on the committee. So let's compute the when x equals to 1. How would you compute that? If we're just thinking about the, still use the old formula, and what is going to be the sample space in this case? We just want to choose random 3-person out of the 30 plus 20, which is 50 people. That's just going to be C53. And what about the events here? So we want to choose 1 senior to be on the committee from the total of 20 seniors. And that should just be 20 choose 1. And I also want to make sure the other 2 spots are occupied by the juniors. And that should be 30 choose 2. And this is your probability for getting 1 senior on the committee. And what about when we want to get 2 seniors on the committee? So this one should still be 20 choose 2 and times 30 choose 1. All right, and for 1x equal to 3, you will have a similar one, which is 20 choose 3. And this will just be 30 choose 0, which is 1. And 50 choose 3. And then you just multiply the first one. You just multiply this one with 1 and 2 and 3. And then you add them together. This will give you the expected number of seniors on the committee. And I think this ends up to 1.2. Okay. And I think right now it's the time to stop. If you have like any other questions, you can leave and ask us. Otherwise, you're free to leave.
The review on Monday will be just during the normal TA hours. So I'll have mine from